Okay, so we're going to go through the answer to question 1, part C, from page 284. And this is a flow rate question. And in this case, it's a flow rate of water through a shower. And by flow rate, what they'll generally be looking for is the mass of the substance, in this case water, per second. So remember, a rate of anything is something per second. Now this question contains an awful lot of information, so it's worth spending a bit of time tidying all that up before you go on to trying to solve the problem. So the question is talking about the heating element of a shower, which has got a power rating of 5 kilowatts, which is the same as 5,000 watts. And it's worth making yourself a little note to remind yourself that power is energy divided by time, because that might be useful later on in the question. So they're testing the accuracy of this value. So we're testing to see if it is indeed 5,000 watts by measuring the rate of flow of water and the temperature before and after. So they go on to tell us the temperature to the supply and the temperature after it's been heated. So from that information we can work out the change in the temperature, which is going to be 36.7, take away 17.4, which is 19.3 degrees Celsius. We can get that done. It says the rate of flow of water is going to be 3.6 times 10 to the minus 3 metre cubed per minute. So the flow rate is 3.60 times 10 to the minus 3 metre cubed per minute. So you can see that they're not giving us the mass per minute, they're giving us the volume per minute. And that's because later on they're going to tell us the density. So the density is equal to 1,000 kilogram per metre cubed. And whenever you see density being given to you, it's worth reminding yourself that density is the mass divided by the volume. Okay. So what do we know? We know the number of metre cubes per minute. Well, we're going to be using a specific heat capacity in a minute, which involves mass. So if we know the density and we know the volume, we can work out the mass, can't we? So let's have a go at that. So the mass per minute is equal to the density times the volume per minute. So that's going to be 1,000 multiplied by the volume per minute, which is 3.6 times 10 to the negative 3. So the mass per minute is going to be 3.6 time kilograms per minute. Okay, now obviously this isn't particularly helpful to be in terms of minutes, we want it to be in SI units, so we're going to go to mass per second. So we just do 3.6 divided by 60, which will give us 0.06 kilograms per second. Okay. Right, so we've done all this work. We don't seem to have got many marks yet, do we? But we will have got marks for this already. So it says, show that the power of the heating element is approximately 5 kilowatts. So we're going to go, so energy equals the mass times the heat capacity times the temperature change. We're told the power, which is energy divided by time. So the energy divided by time is equal to the mass divided by time times the heat capacity times the temperature change. So I'm just dividing by time on both sides of the equation to keep it fair. But the reason for that is this is the power. That is the mass per second that we've just worked out. Heat capacity, temperature change. So now we're in a position we can just pop the numbers in. So the mass divided by time is 0.06. The heat capacity is 4,200. And the temperature change is 19.3. So the power is 4864 watts, which indeed is approximately 5 kilowatts. So that's the first part of the question done. Part 2 was to state and explain a possible source of uncertainty that might affect the reliability of the test. So this is a sensible sort of realistic sort of example. So you might say something like the input temperature of the water changes. It's not necessarily always going to be 17.4. It might be less in the winter and more in the summer. Or you could say that this is assuming that the flow rate remains constant, so the water pressure might change, which would alter the flow rate, which would affect our results.